Emanuele.
Hey, hi. So, who knows about this? Okay, I'm gonna start with a question. So,
Who knows about?
what is this? No idea. 1974. Nobody. 1974. Pirsig publishes Web and the Art of Motorcycle Maintenance. No? Nobody? So
1984. We know.
no. 19, so that book defined the generation, and it's considered. It became the philosophy book that sold the most copies.
So it's a philosophy book, not
It's a book of
not a motorcycle book.
No, it's a book about philosophy, and it summarized really well what was the American counterculture. Okay? I'll get back to that later. So normally I start the talks saying who I am, okay, and it's not to brag about my achievement, that by the way I think are very little, but it's more to show a little bit the itinerary that I've done over the years. There is a bit of philosophy here as well. That is, the universe is a very big place, and I kind of agree with that is another classical movie. Those of you know, guys, right?
Of course.
Yeah, everybody. No,
No.
no.
It's a Blade Runner.
Blade Runner.
Tears in the Rain scene?
Yeah, and the guy at the end says, I've seen ships, galaxies, etc., and all will be forgotten, like tears in the rain. Because there is this very interesting notion that the universe is infinite, and etc. And while if you take an approach like Camus and the Sisyphus complex, you go towards absurdity. But the point is that if you are not religious like me, and the universe is infinite, and etc., really what drives you is curiosity and trying things and exploring and doing as much as possible. Just because while everything out there is infinite, what you have is just your finiteness. So I've done a few things. Most of the time I had a lot of fun. Okay. I am a mathematician, and that's where I start. Well, that's where I started. So I started my journey actually spending 5 years in front of a blackboard, trying to prove a theorem that was basically showing that if you have a plane and you fill it with sensors and you collect a lot of data, the plane has an extremely high chance of crashing. I've done a few inventions as well. I have something like 30 inventions in my name around the cryptology, large-scale models, etc. There was a point as well in which I was actually playing with the supercomputers and actually build the models to realize this kind of stuff, that is basically autonomous ships. And this is the guy, by the way. This is Pirsig, that is the author of the Zen, and etc. And that was a little bit the philosophy of the counterculture, etc. in that period. That was actually saying, as a reaction to what was, the main American consumerist middle-class approach, etc., was saying, go out and explore. Okay, let's stop with this nonsense, etc. Okay, so now I don't have a motorbike, but I have a Vespa. It's down in Italy, so. What am I working on at the moment? I'm working on two things. Okay, so I am the technical co-founder of Provably. Some of you actually already seen that at the Verifiable Summit. Okay, and I've also an academic position at the University of Warsaw under Stefan Jębowski group. So when I am at the University of Warsaw and I work there, my main project is around oblivious RAM and trusted execution environments. So it's basically how to build microarchitectures that can help crypto systems to be more secure rather than fast. Okay? I call it catch me if you can, because it's the idea that the information has an expiry date. And so you actually want to be slow rather than fast when you try to secure that information, and vice versa when you try to discover it as well. For this audience, more interesting, it's probably. So Provably is a project that started almost like a hobby. It was something like last December. It was myself and a few friends. And we decided to understand and to see if we could do verifiable SQL. That is basically, if I have a database, and it is private, and a user wants to do SQL queries, but the user should not have access to that data set. Is there a way such that you can release results that show that the query was done correctly, etc., etc.? The first iteration that we had, that is actually the one that is in our alpha, used a combination of very classical cryptographic systems and primitives. We are now migrating to Tabloid, and we are working hard on that for the first quarter of 2025. Anyone that knows what Tabloid is? So Tabloid was not done by us. It has actually never been published. It's in a blog that came out in November 22, if I'm getting the date right. It's a blog that came out under a project of Protocol Labs, and it was written by Matteo Campanelli. The point of Tabloid was, can we build the queries on verifiable tables? So therefore expanding the SQL thing and actually saying there are queries, etc. And we are working on that, moving away from the current protocols towards more set memberships, etc., and some holding scheme as well. So I'm going to speak a little. So if nobody has questions up to now, no? I'm going to give a little bit of what I call zkP folklore. And actually, the thing I wanted to start was from here. So this is, you know, we see cryptography now, zero knowledge, with the blockchain revolution, etc., etc. But this is how it was cryptography in the 90s. Okay, and this is a lecture that was given by Pranel from KU Leuven this year at the chess conference.
He managed to insult all cryptographers, academic cryptographers, in this report. It's very funny, especially if you know them personally. And both the looks and their talk. So the NSA people really had fun. So he says that 3 of the 4 last sessions were of no value whatever. So they're good scholars, but what they do is completely rubbish. It doesn't really deal with any real problem. Okay? And then there were no proposals of crypto systems, no null cryptanalysis of all designs, even very little on hardware design. So the NSA is kind of saying, this Eurocrypt thing, why did my management send me here? It's not useful. But of course, the NSA is fantastic. Let academics do the useless stuff, and then we can actually hack the real world. And so they actually were happy with this. They were doing the wrong things in their view. And then, of course, another recommendation, which at the time there were no smartphones. So about the knowledge session, he said it was very good because I brought something to read. So because you had to actually think in advance that you had to bring something, and many other sessions were improved because he actually brought some reading material to the session.
So the point was, in the 90s, zero knowledge, it was really just an academic exercise, okay? Even the NSA was laughing at it. If you were a cryptologist, getting a job outside of academia was, you ended up, programming C++, etc. But in the last decade, with Web3, etc., zkP is all over the place. And this actually reached an amazing, level of maturity. Rollups came across, etc., etc. So what happened though is that the focus has been so much on blockchain and Web3 and the development has been so much around the snark that the approach is typically you represent everything as an arithmetic circuit. Okay? And then you translate it in AR, Plonkish, etc., etc. There are zk domain-specific languages, like you all know them, so Cairo, Circon, etc., etc. But importantly to us, as probably, is that there are also attempts to move away from this paradigm and actually to consider approaches that are RAM-based. Anybody knows what is a RAM machine? Yep. No? So there are usually, there are 3 or 4 theoretical computational models. You all heard about the
You mean random access?
Yeah, the random access machine. Okay, so in these basically these random access machine approaches are sort of contrasting in respect to the algebraic circuit ones. And the interesting thing is that these architectures do not need the arithmetic circuit translation. So, for example, in the zkRAM, that is this paper, the idea is actually to be able to build a zero-knowledge proof system just by using a C. Okay, so just a general C grammar. As well. So we all know, and as well, you all know that the sort of metrics and the parameters in zk proof are security, performance, the type of setup, prover and verifier, the runtimes, the proof size, and in most of the modern zk proof systems, the time required for running prover and verifier are linearly proportional to the number of gates of the circuit. Now, you know this guy here, right? So if you are a linear, it's good, but it also sucks, okay? Because it's okay when you have a few gates, etc., etc. It's okay when you have a few megabytes of data. It's not okay when things grow. Of course, you don't want to be there, right? You know, factorial, etc., etc. But the attempt, the stress is all the time. We have to take down that linear complexity at least to logarithmic. Now, constant is the holy grail, okay? But logarithmic is really what everybody tries to do. Okay. So, what are we doing, basically? This idea of verifying general SQL queries, there has been a few results in the last years. So, there's been Verify SQL, there has been zkSQL, much more recent, IntegrityDB, a bit further back in time. They have all been very nice academic approaches, okay? Really amazing papers, a lot of citations, etc., etc. Bloody hard to implement, okay? Really difficult. IntegrityDB tried really hard, etc., etc. There is an amazing GitHub. The thing does not scale very well. It's very clunky. But the question then becomes, why don't you do gates, circuits, etc., etc.? Because this is the problem, okay? So if again, the goal here is a modern database, okay? Database, relational, rows, columns, etc., etc. So if I have, and that's pretty normal, 1 million numerical value, it's a normal database. It's nothing, we're not talking about, the entire internet or etc., etc. It's just a normal database. If you want to use something like Snark to build that, you have to build a circuit that contains more than 1 million gates. Yeah, 1 million gates, it's pretty much at the boundary of what circuits can be. building a city. If you think just if you build a gate with for SHA-256, 6 rounds, etc., without any optimization, any clever tricks, etc., you are around I think last time I checked 60,000 gates, more or less. So from 60,000 to 1 million, it's a very long way. We as Provably, therefore, we propose a system that verifies analytics-based or SQL aggregate queries using cryptographic tools and not relying upon general zk proof systems. We express them in high-level SQL-like syntax, and we don't need to do the low-level formatting, and everything is understandable by any data analytics practitioner. Everybody uses SQL. I've talked about this in the past, and what I wanted to talk about today, and I often didn't talk about, is where does this start mathematically? Because as I said, so we basically developed this first interaction with a trinity of Boolden proof, Pedersen commitments, and Verkel trees. But the reality is that it starts a little bit earlier than that. It starts from inner products. So inner products are a very simple but sophisticated mathematical tool. Okay, they came across in the 19th century, rarely defined. Hamilton started using them. He actually introduced them together with the quaternion. Dirac in the 20th century came up with these bracket notations and started to speak about inner products. It was a very sophisticated thing that then was at the core of quantum physics, for example. But they are very important because they are fundamental in fields such as geometry, linear algebra, functional analysis, and also because inner products lead to what they are called Hilbert spaces. Hilbert spaces allow what is called prediction of physical phenomena, and it's thanks to Hilbert spaces that we can build accurate models that predict the fluctuation in some of the standard models in cosmology, the distribution of large-scale structures of the universe, etc., etc. So inner products are part of the universe. This is the point. But what is an inner product? So let's start from there. So, and stop me if you have a question or you don't understand. Okay. So it's a vector space. Everybody knows what a vector space is? Yeah. Cool. Then I have a field F. Everybody knows what a field F is, etc., etc. So I build this function then, this guy in brackets, from v times v that outputs into the field, and for each uvw in v and ab in the field, I want to have these three properties. So I want to have a conjugate such that uv is equal to the conjugate of that guy. I want to have linearity in the first argument. So as you see here, I have linearity there and there. And very importantly, I want it to be positive definitive. This might not be so important in cryptology, but it's extremely important for statistics and other type of applications. If I define it over a real vector space, Rn, so the standard inner product is defined by, now given that u should be equal to u1, u2, un, and v should be equal to v1, v2, to n, then it's just, multiplication element by 1. If I want to do it in L2, okay, who knows what is a L2? Yep. Okay, so L2 is important. L2 is important because it's the space of integrable functions, and integrable functions are everywhere in everyday life. For example, it's thanks to an integrable function that you can manage the faucet of the sink over there. And let me go to next. And I actually need a glass of water, if you excuse me, sir.
I'll bring it.
Okay. So let's look a little bit of applications of inner product and what they are at the core of. So they allow the measurement of distance and angles. So thank you. Okay, thank you. Who knows what is PCA? Principal component analysis. Yeah? Cool. So without inner product, you don't have PCA, because inner product basically tells you that you can show the quality between the variance in principal component analysis and what they are called the Rayleigh quotients in the algebraic representation that comes by representing the data on the matrix. And so therefore showing that correlation and covariance are derived and they go together. They prove orthogonality. Again, a lot of using principal component analysis, but a lot, extremely important, is support vector machine and kernel methods in machine learning. And Fourier analysis as well. So Fourier series and transform involve inner products with the sinusoidal. What happens instead in crypto, in privacy enhancing technologies? So inner products are at the core of SNARK as well, because when you do a QAP, so you have to combine vectors of variables and coefficients to evaluate polynomials operations that are crucial to the QAPs. They are important in homomorphic encryption, not FHE, but homomorphic encryptions like, for example, if I remember correctly, and now I don't know, I think, no, sorry, that's very far on. They are in CSSK in terms of one decommitments that is used inside the protocol. They are very important for the compactness, for bulletproof, for example. They were part as well of Pinocchio, everybody knows Pinocchio as well, and the Stark as well. That is the non-trusting start version of Snark, more or less. Again. They are also at the core of VDF, verifiable delay functions, that I think, if I remember correctly, are used a lot in the, what's the name of that blockchain? Kia? Something like that? I did not hear, sorry. I'm gonna cheat.
Is that Facebook one or?
No, Libra was the Facebook one. This one was the... Which blockchain was this?
Are you?
Hmm?
Are you?
Me now? Do you mean
No,
VDF?
no,
Are you talking about VDF now or?
I'm talking about VDF, yes. No, Kia. It's the Kia. So they use verifiable function with the inner products. And they are also used in Libra. I don't think it's called the Libra anymore, by the way. They changed it.
They changed the name so many times.
Yeah.
Nobody follows anymore.
I don't even know if they exist
I
anymore.
think the project is fell apart.
Yeah?
They split into
Something
Sui
with G and stuff.
Aptos.
Actually.
Okay.
Things from there. Yeah.
Okay.
Search them.
Yeah. I think what was the name as well? He went back to university, right? The UCL guy that was.
But there are also spin-off, like Sui is a spin-off
Yeah.
from Libra.
Okay, anyway. So, but you know, if you have done again a lot of zk, etc., your objection could be, yeah, but reality is that we want what is called an inner product arguments, not an inner product per se. So basically, what we want in zk is actually to prove that an inner product was computed without knowing the elements that went into it, and that it actually gives a proof. So, an inner product argument allows proving the quality of inner products without revealing the vectors themselves. used in cryptography, especially in zero-knowledge proofs. So we want basically to prove that the inner product of x and y is equal to c without using a zero-knowledge, sorry, by using a zero-knowledge proof. How do we do that? So we build a commit of the first vector. We needed to add some blinding factors. Everybody knows what blinding factors are? No. So in certain protocols, if you just commit a value and you don't add an extra degree of randomness, you risk what is called the man in the middle attack, or you also risk the soundness of the proof. That is basically, an adversary can start to create fake proofs, etc. And so basically you add this randomness. Another way of doing that is with the hashes, but we don't. I'm not going to discuss it here. The prover generates a proof, pi. And then there is a verification a verification check, such that you verify that Cx, Cy, the results in the proof is true or not. Generally speaking, for inner product arguments, we use homomorphic commitments, and very importantly, bulletproof. It utilizes these concepts to provide efficient and private proofs in the blockchain applications. To make it non-interactive, normally you apply a Fiat-Shamir transformation that uses hashes, etc. Everybody knows the difference between interactive and non-interactive. Yeah, okay. This I'm gonna skip. I'm gonna go directly here. Give me 1 second. Yeah. So let's look at an example. So I have a vector A, A1, A2, A3, B, B1, B2, B3, and the inner product target is A1, B1 plus A2, B2 plus A3, B3 equals C. I want to prove this equality again without revealing A1, A2, A3, B1, B2, A3. I have to communicate these values, okay? There is what is called the communication overhead. So I have to communicate each product, A1, B1, etc. Those are what I call free units. And I have to communicate each element, AI and BI, for the proofs or the commitments. Those are other extra 6 units. So the total cost in terms of communication is 9 units. So it is a linear, okay? We started with 3, okay? Basically, the dimension of my problem was 3, and we have reached 9, okay? If you remember that scale that I showed you, it was basically, so we are in the linear range. Linear range, again, it sucks, okay? It sucks because we have only 3 here. We want to deal with the databases that sometimes have rows of hundreds or even thousands. If we start to have this overhead of communication, we don't go anywhere. So, and the reason why I showed this is that because so everybody was using inner products, okay? In 2017 came out the famous bulletproof paper. Actually, Rafa and Dow talked about that in his blog. Okay. So bulletproof was, the new kid on the block, a great tool, etc., etc. And it's an amazing piece of maths, etc. But a lot of people forget that bulletproof would have not happened without this paper. Okay, because in this paper, Bottle and the others actually overcome this thing, so the linearity of inner products. With the linearity, bulletproof and everything that came after would have been totally inefficient. But so the group there basically said, hold on a second, so we are communicating everything, doing that way, etc., etc. Why don't we try to use a technique that it's obvious, but it was not, okay? And you see, we are gonna split the vector into halves. So I had A1, A2, A3, now I take A1, and then I consider the other two. I do the same for B. And now I compute the inner product only between these subsets that I have created, okay? And I keep going, okay? I basically build what is called a recursive method. And when I look at the communication, I see that I am communicating only 3 units. So suddenly, because of these splitting techniques, we managed to take down, they managed to take down the complexity from linear to now it's logarithmic. And that was amazing because basically it managed to create a technique for proving inner products that significantly reduced the complexity of the system itself. And I'm gonna stop with the maths a little bit now, so you can make questions, if you have any. Now it becomes much lighter, okay? So if no questions, so what I'm gonna go a little bit back to what we are trying to do. So we offer verifiable zero-knowledge analytics computations. As I said, you have a database, it's private. I am a user, and I want to run SQL queries on it, but I cannot have access. So I run my SQL queries, and I need to know that the result was computed on the selection of the data that I wanted, and it was computed correctly. So we needed to provide 3 types of proofs. A correctness proof that the query answer has been correctly computed. A completeness proof that all and only the records satisfying the filter as in SQL, contribute to the answer. And the membership, that is all the values which contribute to compute the query's result belong to the database columns specified in the query. How does it work? Very quickly, again, this is just a very generic architecture, nothing fancy there. We have an easy-to-use domain-specific language, DSL. We use a parser to make sure that the queries are correctly formed and compatible with the features. We have a data fetcher that interfaces with the underlying relational database. We have a prover that connects the customer database and computes the results and the proof. We have a verifier. And then we have the underlying protocol of cryptographic primitives. The building blocks are the Pedersen commitment that is used as a basis to compute correctness and completeness proofs. The non-interactive Chang-Pedersen proof that is used to provide a zk equality proof, providing that a hidden value is equal to another one without disclosing it. And the bullet proof. These are all work, and we choose those 3 with a very specific reason. Aside the fact that we needed to find something that allows for dealing with a lot of data that was not arithmetic, circuit-based, etc. We also wanted something that we wanted primitives that have been around a lot. In the same period in which we were starting to design it, well, not the same, but same as in the neighborhood of few months, Nova got hacked, or the folding scheme was basically that was the first zero-knowledge hack that was discovered. But the first blockchain.
You mean mathematical?
Yeah, mathematically. So basically, I don't remember who, but basically there was a blog that said, at this stage, etc., you're basically revealing everything. So we wanted something, especially bulletproof, that had been hacked, repaired, etc., etc. So that was mature enough. And also, one of the advantages of bulletproof is that it came with the Dalek repository. So the bulletproof Dalek repository is a repository open source that has been developing bulletproof since the paper came out. It's in Rust and it's extremely robust. And there are tons, well, not tons, but several cryptographers, Rust coders, etc., that continuously work on it. The same as well, non-interactive John Peterson, it has been around for, 10 plus years probably. And the Peterson commitment as well. And so that's what we built. Recently, we came up with another idea as well. So we have always thought that we have built a screwdriver. Okay, it's a nice tool, verified SQL or where we are going. As a, let's call it as a business model, we always thought we sell the screwdriver. Who wants to buy it, buys it, etc. But then we started to interact with the partners, potential customers, etc. And this idea started to be born, the idea of what we call the data collections. So the idea, everybody knows what Kaggle is? Yeah. So, Mark? No? Kaggle.
It rings a bell, but
It's
another competition.
Yeah. So Kaggle is a platform where you go in and there are machine learning competitions, and they store a lot of data as well. So, and the idea was, why don't we do the same? So not the same, but a very similar idea. That is basically we introduce what they're called the data collections. So there are a set of private data, not maintained by us, but basically some of our partners. And they are there, and you as a user access Provably, and you can gain insights into those, from those databases, from those datasets, without actually accessing them. So one of the first partners that we have potentially is, for example, a set of hospitals where they have clinical, data for clinical trials, etc., etc. And they monetize those. They need to monetize those clinical data without revealing them. Okay, so and we have basically built a nice interface, etc., etc. A lot of UI work has been gone. This is actually by today. This is happening. So we finished actually today. We are testing it. So when I came here, the guys were still hammering at the code. And we do everything via, it's hard to see here, but this is all LLM based. So you enter the interface with an account, and you say, you ask, for example, how many AI engineers are there currently working at Google? Okay, and the system automatically translates the natural language query. It translates it into SQL. SQL then passes through the cryptographic protocols, queries the relevant database, etc., etc. There is a search component in there too that we are developing, such that basically you don't necessarily need to know what are the data on the other side, but you have a search function that actually tells you that there are hospital data, there are etc., etc., with a certain data schema. And you get answers, and very importantly, you get answers with a proof. This actually, we just ran it today before I came here, and it works at the moment that now you get them for free. You basically get the credits, and you have to spend the credits over a collection. But interesting as well is that you can then sell the proofs. So if I had done a lot of work into gaining insights and generating proofs of certain queries, etc., then if somebody else is doing the same type of query or a similar one, he can actually buy it from the user that has already stored them.
Are you keeping this data on the server, like from clients?
From client. Now, at the moment,
In the future.
at the moment, it's demo, etc. But yes, so we don't know if to do both options, etc. That we offer private storage services as well. I don't think so. But at the moment, yes, the client basically has everything on their server.
Oh, so on the client servers. No.
Client has the data owner.
Okay.
Yes.
So do you plan on having like a marketplace? Like how?
Yeah.
Yeah.
That's the idea of those selling those queries, etc., etc. The idea is basically now creating proofs cost, okay, and some of these proofs actually, even with the tabloid implementation, they still occupy a lot of space. So they incur computational cost and the space cost in terms of memory. So having the possibility to recycle them and make them useful for somebody else and sell them is something that it seems there is interest out there.
Can you just clarify? So who has access to data?
Only the data owner.
Okay, and they run your software, probably, agents or whatever.
Yeah, they download an agent.
And people come and say, hey, I would like to get this and this data.
Mm-hmm.
Okay, so you need to have some security in place so they don't like cherry pick data.
They don't want?
Like cherry pick, give me first, give me second, give me third.
Yeah.
Aggregates over reasonable big amounts of data.
Yeah. And there is also, it's on our roadmap, basically. There are privacy threat models in which, for example, I could come and say, give me the minimum. Okay. Then give me the next to the minimum. And the next, etc. So if I do 1 million queries like this, I'm gonna get the database. Okay. So we're gonna implement basically privacy threat models to disallow this type of behaviors. At the moment, it's gonna be only on the data owner side. So basically, the data owner on their RDBMS instantiate policies such that they can basically limit the amount of SQL pinging and the type as well.
Database is mutual that you have to tie them to a timestamp or
You have to tie them to what?
a timestamp. So is the underlying database changing?
Yes, but yes, I got asked this question. We don't do data attestation. Okay, meaning
That's the correctness of the
exactly. We just
What do you prove against? So I have a proof that
I have a proof that at that moment in time, your database was like that, and it produced this type of insight.
but there is a signature from the data owner, or what do you prove
There is a
against?
signature from the data owner here. So. This is just another snapshot, etc. And that's it. So,
Honestly, it's pretty cool. Well, I already asked all the questions along the way.
anybody else?
So what prevents the database owner, the data owner, to actually pre-flight the SQL query, filter out the values he doesn't want to show and
Nothing.
no.
You just guarantee it's the other guarantee is on the other side of the
Yeah.
system.
But the data set is committed, right? Like you have a public commitment to the database.
Yeah.
Like this is the hash of the data.
Yes,
Then
yes.
in circuit you prove that.
But only
Act
data
correctly
owner
against
knows
that
the
hash.
hash is real. But the
Exactly.
proof is that the data owner want to give people ability to
But,
So they
but-
cannot change the
generate
data between queries.
aggregates without revealing data.
But this is the interesting thing, okay? So this, put in this way, opens up the possibility of a partnership because we are not web-free, so we are not building a distributed system, okay? But, you know, there are projects even like yours, you know, where you can basically guarantee data attestation. So with blockchain infrastructure, etc. So that would be, for example, a very nice partnership. That now at the moment we have absolutely zero time to think about, not to think about that, but put it this way, to work on that type of integration. We also don't necessarily want to do that, but that's something that would be very interesting.
So you're only solving the query part because there could be second startup like that solving the
Correct.
solving the insert,
Yeah, normally when you look at the what's called the data life cycle, so you start with attestation. So basically, not tampering of the data, provenance, etc., etc. There is that entire phase, and then you move into analytics and analytics under privacy. Then you can also talk about the privacy, etc., of inferences. So we want that segment in the middle. Okay.
Like I could, for example, use Marek's product to log into my bank account and then generate a data set, and then Marek's product would attest the fact that this is a correct data set, and then I can use Provably to like a lender to let them like analyze my credit
you
score.
need something in the middle because, like, let's say you insert all those web proofs, whatever, to the database. How do you know the database is correct?
No, you don't insert the web proofs in the database. You just, well, I don't know if Relayer necessarily do it, right? But imagine I log into my bank account, proves TLS notary, and then I just click like that. I download the CSV file with all my transactions, and then I hash it, and then I publish the hash of it,
Yeah.
and then Provably kicks in, and I
Yeah, but the
start
question
running
is
queries
why?
against it.
Ah.
And the CSV is not the CSV is notarized by it's not a.
And you need, decentralized. The best would be to have decentralized system that does the notarization, because then otherwise.
Yeah, but that already exists. I mean, if you are using TLS notary, then you just
How
have the
do you
signature
know-
from your bank.
Something is still missing in the middle. Let's say I have CSV and a hash of the CSV, but I need to load it to the database, no? Or can I query?
I mean, a CSV
Raw
is already a
CSV.
database kind of, right?
Can I query CSV?
CSV is
No, you need
a
that.
table, so why not?
Yeah, like you just put it in a database. The hash isn't going
Yeah,
to change.
but the hash gonna change, right? So you
No,
need
it's-
to prove the hash to hash conversion, right?
No, like you can run a database like an engine on a CSV file.
Oh,
Like,
you
or
mean,
SQL
you mean I
file.
select?
Yeah, you can select a CSV file. It's
The database inside the
I calculate the hash of the CSV in Solidity the same way I'm gonna calculate the hash
Yep.
in the database. So you have two queries: one to authenticate data, select star from star, hash it all, and the second actual.
Yep.
Makes sense. Pretty cool.
So
I was thinking about zkSQL like 2 years ago, but I was actually thinking about solving the other side.
Yeah.
I mean both sides, but I was thinking a lot about proving inserts and updates and all that stuff, and having like a one hash, like series of hashes.
Yeah, because blockchain Web3 needs more depth rather than this side. This side, it doesn't necessarily need consensus, etc. There's no need for immutability here. Here are single databases. So, although it might, we're talking about that with the deforest.
Depend on maybe it's just
Yeah, exactly.
you don't do one.
why do
You have
you use it like it's I'm just asking because like it seems like sort of old choice, like compared to all the shiny clones and stars that we have? Like, why is it bulletproof?
Yeah, well, because it doesn't need a circuit. Okay, it's a range proof that works without a circuit. It's based on the inner product,
Okay.
and it can scale up. Okay,
What kind of queries can you run with that?
But what,
Like
I
you-
mean,
you-
you could argue the same about Star, yes?
Yeah, but the other reason was bulletproof is old. That's good. Okay, that's good that it's old because it's mature.
Proofs are small.
More, I mean, yes.
Is it constant or locked size?
Constant.
Constant?
Constant?
No, wait.
Bulletproofs are huge and
Yeah. I think like
bulletproofs isn't bulletproof just like square root of something.
Yeah, bulletproof are kind of. That's why we're moving to tabloid because they are okay for now. I don't know if I have everything. Let me check.
It was the first system without a trust system.
I remember.
Do I have it here? I don't remember.
Very,
No,
very.
No, I don't have it here. It's okay till we are around 100,000, 200,000 type of databases, rows, etc., etc.
What kinds of operators do you support in that in SQL? Like, what's the
It's not on chain.
I have them here, so this is what we support at the moment.
And
There's not
queries.
Here, these are the aggregates.
So it's like select, where.
I don't remember if I have another one.
Oh,
So- These are the filters, the aggregating queries. We support Postgres at the moment.
Oh, nice.
from the client side, like if I'm a hospital or an NBA team, then I just have my data in CSV. I download Provably. Provably doesn't have access at all to, like, you cannot see the files.
You download your Docker image and you run it.
And the other side also installs Provably.
They are all Dockers.
And what about things like joins and
Uh,
where and heading and other classes?
Join is one of the toughest. In fact, we have it with tabloid. It's extremely hard to do joint with the bulletproof headers and etc. etc. With the tabloid, basically by changing the protocol to set membership, it's possible, but it's gonna come at the end of Q1.
I think that's like very important one to have joined.
Yeah, again, it depends. Okay, I mean, yes, it is very important. You still can do a lot of stuff without.
Yeah.
But yeah, I get that question usually when is joint done.
And then, what if the LLM just messes up something?
Like what?
Like just makes a mistake and doesn't give the correct data.
Don't know. It's a good question.
Might make a mistake in the calculation.
Well, it's just UI thing.
Yeah.
Like the core functionality is.
Yes, they are put in this way. They,
But would the proof fail then? Would the proof fail then, or I mean?
no, it just
Like just the
So-
LLM will write the SQL, right?
yeah. So where the LLM can fail is to do the wrong translation.
Yeah.
Okay. But then you can see, okay, in the backend or etc. You can see that the queries have been run. And actually, we show them. Do we show them already? I don't remember. Yeah, you see, they actually get shown.
Oh, okay.
So
So you can correct it if
you can, yes.
That's very cool.
Pretty awesome.
Like, what kind of companies are interested in?
At the moment, basically, we have discussed it with hospitals. We have had a conversation with the European Army, but I have to be honest, that's so slow that they are probably gonna die first by being killed by Putin, etc. So we got a lot from. Hold on a second. So we have I think 3 partners. Cheyenne knows much more about this than me. So we have 4 partnerships again announced. One is GenLayer, I think, and it's basically an AI company, and they needed to train their LLMs, etc., on private datasets. Okay, so they're gonna use this, and then I don't know.
Okay, oh, that's super nice. So it will be like the first use of zk beyond blockchains ever, maybe, or like in practice.
Yeah, well, I mean, I don't know.
One of the first. I
One
guess.
of the few
Yeah.
One of the, yeah,
at scale.
Oh, it's easy. You know, it's like a great achievement, I guess.
Like the government should be obligated to like publish all the data in that way, like about taxes and all this.
yeah.
Yeah.
Right?
So it's a big news. Nice.
Thanks.
One more time, then. Right?
Thank you.